Hello, Shabby Shambles here. So last video we went over the hardware structures involved in launching a computer and loading the OS. Here we're going to go over actually coding the OS and what files we're going to use to do that. So here we have four files. We have loader.s. This is going to be written in assembler. We have kernel.cpp, which is going to be written in C++. In C++, we have loader.ld. And we have our makefile. So let's start with our makefile. So the obvious question is, what is the makefile going to do? The makefile is going to, one, combine our files into kernel.bin, right? Because remember, we need kernel.bin to load into the RAM and then launch our operating system. So kernel.bin is going to be stored on the hard drive and then it's going to be loaded in to the random access memory. So the way to think of the makefile is it's like a recipe book. It contains instructions to our Linux implementation to create kernel.bin. So these instructions have to be in a certain arrangement. They have to be target, right? They have to be in the syntax of target, right? Target file or target instruction. This doesn't have to be a file. Prerequisites. A tab character, and then the instructions. So this is going to be for any makefile, which we're thinking of like a recipe book. So this is the individual recipe, right? This right here, this target file, is the dish we're trying to make. The prerequisites are the ingredients, and the instructions down here are how we're going to combine those prerequisites to come up with our target file. Now let's talk about kernel.cpp. Kernel.cpp is our main character. It's our main character. It's the star of the show. Okay? It provides put that down here. Provides all the functionality our OS is going to have. Now, for our purposes, this is going to be written in C++. There's no reason it has to be written in C++. But for our purposes, we are going to write it in C++ because we get to take advantage during the creation of kernel.bin of our Linux operating system. But when we are putting kernel.bin through the bootloader, We don't have the advantage of any of the dynamic link libraries that are included in our implementation of Linux. So we don't have things like stdlib or stdio or any of that. We have that in our Linux implementation as we're coding this, but when we put it into the kernel.bin and then put it through the bootloader, we've left our Linux implementation. So if our Linux implementation has these dynamic link libraries installed, when we move outside of Linux, when we move outside of any operating system, we don't have the benefit of that. So we have to code this in a very specific way, taking advantage of only the basic C++ functionality in order to get where we want. And I'll show you all the code later on. I'll link to my GitHub, and it'll be on there. But I want to give you an understanding of what we're doing and why we're doing it. So kernel.cpp is our main character. It's the star of the show. The loader.s here, is our hype man. It's going to tell the bootloader how to approach our kernel. It's the Flavor Flav to the kernel's public enemy. It tells our bootloader how to navigate the kernel. And because it's communicating directly with the bootloader, it has to be written in assembler. Now, the loader. The loader, I'm a little bit unclear on. I followed a tutorial, read a bunch of stuff, and I'm a little bit unclear still on the loader. But I do know what it's doing, and I do have a sample bit of code written up for you that you can take a look at. So the loader is translating, linker.ld. I've been saying loader the whole time, linker. So it's going to be translating our loader under kernel to the makefile. So the linker is taking kernel.cpp and loader.s, which are written in different languages, and it's translating from those languages. It's almost like kernel is written in Spanish and loader is written in Mandarin, and linker is translating both of those into a language that the makefile can understand. Right? So let's go through it, and then I'll show you the code and go through the code with you. Kernel.cpp is our main character. It's telling the computer how to run the operating system, what we want the operating system to do. The loader, over here, the loader is telling the bootloader how to navigate the kernel. It's the hype man. It's the one who tells the computer how to approach the operating system. The linker is translating our loader and our kernel into a language that is common so the makefile can understand it. And the makefile is combining the loader and the kernel. First, this is important actually. First, loader and kernel into -o files, into object files, then combining the linker and the objects into .bin. So the makefile is a recipe book, and we are putting in the recipes to the makefile, and we are going to end up at the end of it all with kernel.bin installed into our /root directory. Now let's go through the files one by one. Starting with the kernel. The kernel is pretty basic C++. All our operating system is doing at this point is printing hello world and running. Printf hello world and an infinite loop to run. Now, we don't actually have the dynamic link library standard IO. So we need to define our own printf function. And we're doing it using this hexadecimal value right here. Because this hexadecimal value is the value that will be chosen by our computer, by the hardware, right? So we are working really, really close to the machine. We are putting our string, hello world, into the spot in random access memory that the video card, that the graphics card will access and put on screen. All right, we are putting hello world onto the screen because the graphics card will check this memory value for things that it should put on screen. Now let's go to the loader. The loader we'll get to this in a little bit. But the loader is moving the stack pointer. The stack pointer, remember that's in our CPU. Our CPU has a bunch of registers. And the stack pointer, it's moving the stack pointer to this value, kernel stack. It's pushing information in some registers, EAX and EBX. These are some registers on the CPU, and it's calling kernel main. Calling kernel main, right? And so we see over here multi-boot structure and magic number. That is what this code right here is pushing multi-boot structure and the magic number over into kernel main. And so what is this magic number? Well, the magic number is what's going to tell our CPU that this is a valid kernel, this is a valid operating system. It's a key. Your CPU is going to ask, hey, can I see your qualifications? And we're going to give the CPU this number. And it's going to say, okay, checks out, looks good. Now, this down here, this underscore stop part of our loader.s is so if we ever get out of kernel main, which can't happen because we have an infinite loop in kernel main, but if we ever do, this is going to loop infinitely as well. Now this section.bss. This is buffer space, right? So we have variables here that are going to be in a multi-boot structure that is going to provide to our CPU the evidence that this is a real, legitimate operating system. We have some code that is saying, hey, kernel main exists, and this is the loader. And we're moving this kernel stack, we're moving the stack pointer to kernel stack. And then we are pushing the two variables that kernel main needs to run into kernel main. Alright, now let's go in to the linker. We are telling where to load, where to first go into, right? We're providing, when we put kernel.bin onto the RAM, we are going to tell the CPU that is reading kernel.bin, hey, look in the loader first, output in this format, and this architecture. This is what you should expect in text. This is the data that you should expect. You should expect the .bss section. And finally, you should discard everything else. Right? So you should expect the .text section that contains this. This will be the data that you're looking for. You should expect the .bss section that contains .bss, and you should discard everything else. Now, for the makefile. We set some parameters that we're going to later pass in to Linux as parameters in our instructions. We're going to make a .o file out of a .cpp file using G++ and this recipe. This $@ is saying we're making the target file, right? $@ is make file shorthand for make the target out of the prerequisite, the first prerequisite. Right? So out of the first prerequisite, this CPP file, make the target, the .o file. And similarly, down here, we're going to make a .o file out of a .s file using AS, the assembler interpreter, making the target file out of the first parameter file, the first prerequisite file. And again, we're passing in these params, right? We're passing in these parameters. Now, we have mykernel.bin. We are trying to make mykernel.bin out of linker.ld and our objects, which are object files, which are we define up here, right? So we have two prerequisites, linker.ld and our two object files. We are going to use LD that we installed last time. We are going to use the first prerequisite for instructions. The first prerequisite, we are going to create our target file out of our object file. And this is install. Now remember I said our target doesn't have to be a file. It can be an instruction. So we have install mykernel.bin. We're going to say sudo cp, the first prerequisite, to this location. So we're going to sudo install the first prerequisite to this location. /root/mykernel.bin. And that is how you build the files for your operating system.